So we saw about resonance, correct? So again I'm repeating, resonance is a condition where XL is equal to XC, correct? And omega naught is the frequency at which the resonance condition will occur. Now, see, you guys saw the graph for the resonance, right? Where the current was maximum. Now, in resonance condition, the current through the circuit depends on only one factor, that is the resistance of the circuit. Meaning, at resonating frequency, that is omega naught, the current is maximum and the flow of current in the circuit depends on only one factor, that is the resistance in the circuit, right? So, more the resistance you have, lesser the current flows through the circuit and vice versa, correct? So, what we get here is something known as the sharpness of the resonating curve. Okay, so if you look at the graph here, see, we have three graphs, correct? Now, for all these three graphs, we have only one resonating frequency. See, that's the omega naught value. Now, the only difference for these three curves is the value of the resistance. Meaning, the lesser and lesser the value of the resistance, more will be the current. So, for the first curve, let's call this as R1, this as R2, this as R3. Okay, so what we get here is R1 less than R2 less than R3. Understood? So, since R1 less than R2 less than R3, we get I1 greater than I2 greater than I3. Okay, so what we are talking about is the peak current. Alright, so what we have here is, see, what we understood from this is lesser the resistance, more sharp the curve becomes. So this is what we are discussing in this topic, that is the sharpness of the resonating curve, okay, or the sharpness of this particular graph. All right, so sharpness meaning how much of current is flowing through the circuit. In layman terms, you can explain something like this. Okay, now for anything of this particular type of graph, what we have is omega naught, correct? And let's say we have two more frequencies, let's say omega 1 and omega 2. Now, how we choose omega 1 and omega 2 is the current value should be 1 by root 2 times the maximum current value. Okay, that means at omega naught you have the maximum current, right? And at omega 1 and omega 2 we have 1 by root 2 times the maximum current. Okay, so let's say omega 1 is here and omega 2 is here. Alright, so in both the cases, see, we can write these two in terms of omega naught, correct? So we can write this as, let's say omega 1 will be omega naught minus delta omega, and omega 2 is omega naught plus delta omega, right? Now, omega 2 to omega 1, whatever the difference we have, we call that as the bandwidth of the frequency. Okay, so if you look at that, bandwidth will be nothing but 2 times delta omega, correct? So omega naught will get cancelled, so 2 times delta omega becomes the bandwidth of the frequency. Okay, so what we are actually calculating here is the sharpness, correct? So for the sharpness, we need a mathematical expression. So in the next video, you will see about the mathematical expression for the sharpness of the curve.